Hello everybody, thank you for tuning in to the Will Fix Team. Quick video of the day. So, this procedure can be applied to just about any vehicle that's on the road that has a charging system. And I'm going to show you sort of a way to diagnose whether or not this thing is charging and how well it's performing. And so let me go ahead and flip the camera around. We're going to hook it up to a digital voltmeter. Digital is just easy for everybody to use. And then we're going to see what happens here. So what we have here is a vehicle of just generic, good old-fashioned genericity. Now, I have a digital voltmeter. A quick little lesson on these. This is an auto range meter, so we don't have to necessarily set it at a certain voltage. But let me show you what one looks like if it's not. Here's an older, more basic, or not necessarily older, but just a more basic meter. I don't really use it much. I like this meter better. But anyhow, you'll notice that you have an A with a squiggly line, and then you have a V with a line that's got a straight line and a dotted line. Well, that's your direct current, okay? Now, let me zoom back out. I'll zoom back in. So, we're going to be testing between the 0 and, around 12 volt scale. So, we'll flip it to 20. So, if you have one of those older meters, you put it where you can see the DC signal, which is direct current, straight line, squiggly line. Okay, but we're using this meter here. It's auto range, so we don't have to do that. So, we're on our straight line, squiggly line. Okay? Now, something I like to do is I hook directly to the wire on the back of the alternator. Now, alternators vary in places of the vehicle. I'll leave that to your personal knowledge to be able to identify alternators on certain vehicles, but this one's on a Ford 4.6, so it's right here at the top. And the reason why I like to hook right there is I hook in two places. To test to see if I've got a wire connection, make sure a main fuse isn't blown, because some vehicles have a main fuse between that charging wire and the battery. Some of them do, some of them don't. Sometimes the wire itself starts to become corroded on the inside, and you'll see a charge at this end but not really at the battery end. So by testing both places, it gives you an idea of what's really going on. Now, so I have my positive wire hooked onto that. I have a jumper here just to kind of like, sometimes I'll just jump that wire out just to see if it changes any. If I have a low charge or no charge, look for an arc to see that, just to test. And so we have the positive and negative. And yes, this battery is very old, but we're going to hook I used a couple alligator clips. So here's the negative wire, which is black, indicating negative. So I'm gonna hook that right to the battery itself. And then we're already hooked in on the alternator over here, and we can see battery voltage. So let me start the vehicle, and we're gonna see if it charges. Then I'm going to load the alternator and see how well it can hold up. It should still charge 13 volts at an idle. If it's discharging, there's either a problem with the belt slipping, or the alternator itself is performing not very well, or you've got a corroded or damaged wire. So let's see what happens here. Go over here to the key. We'll fire it up. So it seems to be doing pretty good. Okay, so let's load the alternator down and see what happens. We'll load it down by turning on some of the accessories. Headlights. Ooh, you can hear it a little bit. So, ooh. Okay, well, so far so good. All right. Now, let me put a little bit more of a load on it. We're going to turn on. It should still be able to carry these. You hear the alternator actually kind of saying, I'm going to show you something here. Turn on the air conditioner. And this thing may charge pretty good. You may see an alternator put out pretty good. Let it warm up. Let the windings of the alternator get hot. Let it run a little bit, and then you'll start to see. Okay, so we're doing pretty good right now. So I'm going to let the vehicle run for a little bit and get warmed up, and then I'll show you the performance after that's happened. Okay, so we're back. This is after about 15 minutes of run time. You can see now that the alternator is just not putting out very well. That's where we're at. We'll unload it. We'll take the load off. We'll start with the headlights. In real time here. And it's coming up a little bit, but the AC system with the fan on in front of the radiator and also under the dash, that's pretty heavy load. They pull a lot of what they want to call amps or current. And so we'll turn that off. And we'll turn this off here. Okay. All right. and you'll see the voltage start to creep back up. And you can test right at the battery. We'll unhook right here. We'll go right at the battery. Being careful not to ground anything. And we'll see that we're running 1393. We know we're back at the battery over here. You shouldn't do that. It should carry the load. We're going to turn the AC system back on. We're back on there. Okay. And already we're probably discharging at the moment. Let's see. We're headed downhill. Just trying to keep it. See that? Pulling down, little by little. It's trying to keep up. Now I can throttle into this thing and you'll see the voltage come up. Let me set this up in real time so you'll see this. And this helps anybody do it yourself that's questionable whether or not they've got a bad alternator. Let me get over here to the vehicle. Well, I'm gonna turn the headlights on too. Sorry for the camera movement. Let me get zoomed in so you can see this. See, look, I hadn't even turned the headlights on yet. I'm gonna turn those on. And you're gonna really see that alternator beg for mercy as it's slowly headed down to the path of 11 volts, which is not good. Now we throttle into it. We're kind of compensating for the weak. I'm going to explain to you what's happening here in just a second, so stick with me. Okay, so we'll turn everything off because we know that we've got a problem here, and I'm going to flip the camera around and I'm going to explain to you what's going on. So what you see happening, it's a phenomenon where the electrical windings, either the armature or the field windings, are starting to break down. I've had similar instances with, I do a lot of motorcycle repair, where whenever the stator starts to go bad, when you pull the side cover off and you look inside of there, you can actually see the little copper windings as they're wound around each part of the poles, they call that. And you'll start to see a charring effect take place where they get blackened, and then the insulation that you see on the wires, it looks like it's just bare copper wire, has actually got a really thin varnish, a very fragile ecosystem, I would call it, that's inside of that, where it keeps the wires insulated so they don't come in contact with each other. Now, as that insulation starts to heat up, gaps start to form, and you'll actually, if you take the alternator apart, you would start to see the charring and the blackening of the armature and or field windings that are in that alternator as they start to conglomerate and become as one, which gives you less of a surface area for the poles to be able to create the necessary current load to keep up with that. Brushes might not be the case on this here. Of course, that plays a factor. And you're probably going to say, well, the battery is really old. Why don't you just try a new battery in it? Well, I can assure you that that is probably part of the trouble. Being the battery is really old, it's causing the alternator to work a lot harder. And what I've noticed is, once that happens, once the alternator gets to that point, especially working at a garage where people want to pick their vehicle up and not have to bring it back later, you can replace the battery. It might mask the problem for a short period of time because the battery has some more of an ability to hold that charge. And so in between stop and go traffic, it doesn't discharge as quickly, so you wouldn't notice it, because the customer said that it was doing great. They made several quick stops where they got in the vehicle, started it, drove to a destination which was close by, got out, turned it off, went somewhere inside, came back out, restarted it again, drove to. They did that 3 times, so there was not a lot of time in between when you throttled into it and seen the alternator come up and start charging again to put a full charge back into the battery, what's getting a lot of age on it. And this was only after 15 minutes of running. I could imagine if you were driving this car, pulling that load down the road, you would probably see it start to discharge even at RPM level. So I'm going to replace both parts of this, because that way, when this thing's sent out the door, I know that it's going to be right. Our wire is looking really good because we have a consistent voltage between battery and alternator. And the belt's not slipping, because off camera I actually took and pulled with a bar that's used for checking the serpentine, taking the serpentine belt off the tensioner tool. I pulled that thing tight just to see what would happen. Nothing. There's no slipping. So what we can do now is we're going to just replace everything. Well, I'm sure that it will be just fine. I've done this many times. If you have any comments or any questions that you want to address, please put it in the comment section of this video, and I'll do my best to get back to you as timely as possible. Thank you for watching, and I hope this video